Nitrogen monoxide, NO, and oxygen, O2, react to form nitrogen dioxide, NO2, in the reversible reaction shown in equilibrium 18.1. Part A. Write an expression for Kc for this equilibrium and state the units. Kc is in terms of concentration, and in an expression for Kc you include all parts of the equilibrium in the same state. In equilibrium 18.1, all parts of the equilibrium are gaseous, so all parts are included. In an expression for Kc, you work backwards across your equilibrium. So the forwards reaction, which is here, you would do backwards. So nitrogen dioxide would be your numerator. So we use square brackets to signify concentration, and then we're writing to the power of 2. And that is because of the stoichiometry in the equilibrium. There is a 2 in front of the nitrogen dioxide, so it's raised to the power of 2. Then for our denominator, we have nitrogen monoxide raised to the power of 2 multiplied by oxygen raised to the power of 1, so we don't need to write it. In terms of units, well, the square brackets mean moles per decimeter cubed. So if we were to rewrite this equation as units, we would have moles per decimeter cubed to the power of 2 on our numerator, and moles per decimeter cubed to the power of 3 on our denominator. So if we were to expand this, we would have moles squared decimeters to the minus 6 divided by moles cubed times decimeters to the minus 9. So if we were to cancel out this fraction, we can cancel out the moles on the numerator and 2 of the moles on the denominator, so we're left with moles to the minus 1, or moles to the 1 over 1. And then we cancel out the decimeters to the minus 6, and we cancel out the minus 9 and replace it with a minus 3. So that equals 1 over moles per decimeter cubed. Another way of writing this on the answer line would be moles to the minus 1 decimeters cubed. To get the 2 marks for this question, you need to have the correct expression for Kc and the correct units for Kc. Part B. A chemist mixes together nitrogen and oxygen and pressurizes the gases so that their total gas volume is 4 decimeters cubed. The mixture is allowed to reach equilibrium at constant temperature and volume. The equilibrium mixture contains 0.4 moles of nitrogen monoxide and 0.8 moles of oxygen. Under these conditions, the numerical value of Kc is 45. Calculate the amount in moles of nitrogen dioxide in the equilibrium mixture. Firstly, let's highlight the key pieces of information in Part B. 1. That the total gas volume is 4 decimeters cubed, and then the number of moles of nitrogen monoxide, oxygen, and the value of Kc. Because we're given the number of moles and the volume, we can use the equation triangle NV times C in order to work out concentration, which is what Kc is expressed in terms of. If we begin by working out the concentration of nitrogen monoxide, that would be 0.4 divided by 4, which gives us 0.1 moles per decimeter cubed. The same thing can be done to work out the concentration of oxygen, and that would be 0.8 divided by 4, which gives us 0.2 moles per decimeter cubed of oxygen. Next, we need to substitute these values into our expression for Kc. So that would be 45 equals, we don't know the concentration of nitrogen dioxide, so we write that the same as our expression, then divided by 0.1 squared times 0.2. Next, we need to rearrange to find nitrogen dioxide squared, that would be 45 times 0.1 squared times 0.2, which gives us 0.09. Then, to find out the concentration of nitrogen dioxide, we need to square root 0.09, which gives us 0.3 moles per decimeter cubed. Finally, the question is asking us for the amount in moles of nitrogen dioxide. Therefore, we need to do the reverse of what we've done in our first step and take concentration and multiply it by our volume, which is 4 decimeters cubed, and that gives us 1.2 moles of nitrogen dioxide, which is what we write on our answer line. To get the 4 marks for this question, you get 1 mark for working out the concentration of nitrogen monoxide and oxygen. Together that gets you 1 mark. You get your second mark for working out the concentration of nitrogen dioxide squared, which is 0.09. And then you get your third mark for rooting 0.09 and working out the concentration of nitrogen dioxide. And your final mark for working out the moles, which would be the concentration times 4 or volume, and writing 1.2 on your answer line. Part C. The values of Kp for equilibrium 18.1 at 298 Kelvin and 1000 Kelvin are shown below. Part 1. Predict with a reason whether the forward reaction is exothermic or endothermic. Even if you were unsure what the answer was for this question, you can state the trend shown in the table. And that trend is that Kp decreases as the temperature is increased from 298 Kelvin to 1000 Kelvin. And so we can then make a suggestion as to what the forward reaction is. And the forward reaction is therefore exothermic. If you didn't know the answer, it's worth making a revision resource because this is quite a common question and it comes up a lot, so it's really useful to know this very well before going into your exams. To get the mark for this question, you need to say that it's exothermic, or the forward reaction is exothermic, and that Kp decreases as temperature increases. Both are required to get the mark. Part 2. The chemist increases the pressure of the equilibrium mixture at the same temperature. State and explain in terms of Kp how you would expect the equilibrium position to change. Firstly, we need to talk about the equilibrium position and how this is going to shift due to an increase in pressure. So the equilibrium position is going to shift to the right, and I will explain why. And that is because it shifts to the side with a fewer number of moles of gas. On the left there are 3, and on the right there are 2, so the equilibrium position is going to shift to the right. Next we need to talk about the ratio in the Kp expression. And what's going to happen to this ratio is it's going to decrease. And that is because the denominator is going to increase more than the numerator, therefore decreasing the ratio in the Kp expression. And in any question where you're asked about Kp and the effect of Kp, you need to say the final thing would be the ratio increases in this case. It could be decreases, but the main thing is it's going to restore Kp, and this is a phrase you'll write in any question when you're asked about Kp and how it changes due to temperature or pressure or any conditions. To get the 3 marks for this question, you get your first mark for talking about equilibrium position shifting, your second mark talking about the ratio in Kp changing, and then your third mark for talking about the ratio increasing to restore Kp.